Bismillah ar-Rahman ar-Rahim. In this video, I want to talk about cardiac index calculation, how to calculate mathematically cardiac index. So first, the definition. Cardiac output is the amount of the blood that the heart pumps in a minute, So this one definition is the cardiac output. So cardiac output based on body size, patient size, called cardiac index. So cardiac index is cardiac output based on body size. The normal range between 2.5 and 4.2 liter per minute per square meter. Now, the normal range between 2.5 and 4.2. How to calculate cardiac index is cardiac output, the cardiac output, divided by body surface area, divided by body surface area by this one. Now, cardiac output is stroke volume, is the stroke volume times heart rate. What the stroke volume is? Stroke volume is end of diastolic volume minus end of systolic volume. This is the stroke volume. Cardiac output, stroke volume times heart rate. So this represents now cardiac output divided by body surface area. Now what the body surface area formula is? The metric formula is square root W, mean the weight in kilogram, per kilogram, and times height centimeter using metric formula, divide by 3,600. Divide by 3,600. So now return back. Cardiac index is, we have cardiac output, stroke volume times heart rate, divide by body surface area. But now, here we have the stroke volume is N, the stroke volume minus N stroke volume times HR, mean heart rate, divided by body surface area. But see, now this one can be simplified. It can be written as mathematically, this W weight times height divide by this of the root is 60. Then if you have mathematically A divided by B over C, this can be written as A times C over B. So that is means 60 would be, this is times 60, and this is be cancelled, times 60. So then can be written the formula now. This formula can be written as, C can be written as N diastolic volume minus N systolic volume, which is times HR, the stroke volume times HR, cardiac, so this is cardiac output, CO, this one, CO, and over the body surface area, the 60 out of the root will be times 60 as accepted here, This A over B over C can be A times C over B. So now this one 60, this one comes out 60, okay? And like this is now, it is like A, this one, with this one, it is B, okay? With this one, it is C. Okay, now this is the way to write the stroke comes easier in calculation, okay? Okay, now, see, how to now evaluate cardiac index in this example. Example, if end diastolic volume 120 ml milliliter, end stroke volume 50 ml, and heart rate 75 beats, weight 65 kilogram, height 160 centimeter. So how to calculate cardiac index, which is equal to a formula, see the formula, end systolic volume minus end diastolic volume minus end systolic volume. So end diastolic volume, we have 120 minus end systolic volume, it is 50, times heart rate. Heart rate is 75 over divided by square root weight. The weight is 65 times the height 160, and this one times 60 here. Divided by 3,600, that's 60 here. So the cardiac output formula is equal to end diastolic volume minus end systolic volume times heart rate times 60 divided by square root weight times height. Now the calculation is equal to, let's find the calculation. So equal to, now this one equal to, using the calculator by the calculator. So this one is, that is mean from here, I have stroke index, cardiac index equal to, the numerator is 70 times 75 times 60. So this one is stroke volume, which is 120 minus 50, 120 minus 50. And this 75 is the heart rate given here. The heart rate is the heart rate. Okay, times 60 over the square root weight times height, which is over weight 65 kilogram times 160 height centimeter, equal to, now the calculator we have here, the numerator is, we have numerator is 70 times 75 times 60 equal to, so the numerator is equal to, the numerator is, you have here 315,000 divided by the square root, but the square root I have here 65, or multiply 65 by 160. So 65 times 160, which is equal to, so that's mean I have a square root is 10,400. So is equal to, now the answer is equal to, we have the numerator is 315,000 divided by square root 10,400, which is equal to, the answer is 3,088.829. But this one is ml, so divide by 1,000 to be liter. Okay, so because this is ml, so equal, now that's divided by 1,000, 3.08. So 8 here we have 829. Yeah, and that is mean will be this one rounded 3 places, so 3.089 liter per minute per square meter. So this one is the cardiac index within what, the normal range. See, the normal range is, return back, the normal range here we have, this is the normal range, excuse me, this is the normal range is between 2.5 and 4.2 liters per minute per second. So now the answer is within the range, 3.08. Now, if we change, if we change, for example, here, if we said the heart rate increased, yeah, I mean, in this example, if I change in this example, the heart rate, let us say this is the heart rate to be not 75 here, given 75, let us to say the heart rate given here in this problem, for example, we have the heart rate in case if heart rate equal to 90, for example, it is 90. Now, if heart rate is 90, just use the red color, so it can be clear. This is 90, heart rate now 90. What will be the answer here? See, now we have 70 times 90 and times 60 and divide by the square root. We have 65 times 160 times 160, which is equal to, now the answer will be, the solution of this one. See the solution here. This one, if we change this one, Okay, so the calculation in this case, now we have is equal to, if I divide by 1000 also, so it will be 0.707 liter per minute per square meter. See now, it is increased. Cardiac index increased because we have the heart rate is increased. Or if we said, for example, now the heart rate is increased to, in case, for example, that I said 100, for example, 15, 115. So this will be times 115 now. This will be times 115 here. Okay, so times 115. So times 115. So the calculation will be here. Is equal to, see now above the average. So we have 4 point in my calculator, 736, which is what? Above the average. What is the average? So the average we have here, 4.2. Now what you have, the average is the heart cardiac index is 4.736, which is above the normal average. The reason, because the heart rate is increased. Now, if we return back to the same problem, if we said in this problem, or the same problem, if we say, for example, the weight is increased. What about in case if the weight is increased? Now, return back. If I have here that it said, and the systolic volume is 130, for example, in this example, okay, that I said, and systolic volume is, here we have 50, and the heart rate, that I said the heart rate is 80, and we have the weight is not 75. Assume that the weight is increased up to 110 kilogram. Okay, and the height is the same, 160 centimeter. The same. For example, the height is there. What about now what about the answer of this one? Okay, the solution of this one. See, look at here the solution. How to find now cardiac index in this case. In this case, in this scenario, we have the cardiac index equal to end diastolic volume minus end systolic volume, here represent the stroke volume, and times what? Times heart rate times 60 divided by square root, here we have W, weight times height, which is equal to, now we have 130 diastolic and diastolic, 130 minus 50 end of systolic volume times heart rate is 80 beats per minute, and see, don't forget times 60, and over square root W, the weight is 110 times 160 times, so is equal to, now this one 130 minus 50, it is 80, so then we have the calculation is, will be the final answer here, you have 80 and over square root, over the square root is, I have the weight, we said here 110 kilogram, if it increase the weight 110 kilogram times the same height is 160, so equal to, see, equal to what now, equal to 2.895, because I see I'm dividing by 1000, by the way, because this one, the answer is 2895, 94 we have here really, and 50. So the answer in the calculator, the answer the calculator is, see, the answer the calculator, then we have here 28945, this is point 508, and so on, divided by 1000, because this is ml. So the same that example I divided, the same that example already I divided by 1000, this one. So this one 4786. So now divide by 1000. Also this divide by 1000. So we have here 2.894, and will be here 5 3 decimal places with this one. And So, and again, is if we increase here the weight be more and more, see then will be below the point below the range comes if increase the weight. So below the range is 2.5 here. And here still this one, I have the final answer 2.8. But if increase more and more, and if it had to be more, then this will be less than 2.5. This comes. Now a question. If given and the systolic volume 130 and systolic volume 50 ml, and heart rate is 80 beats per minute, and height 160 centimeters. So what is the weight? Equal what the weight? If the cardiac index within the range, for example, 3.5, this one is liter per minute per square meter. يعني is this is L and here given ml. So this will be 3000 من 500 ml per minute. Okay, per this one square meter. So 3500. How to find the weight mathematically? See the solution. The answer, the solution. We say that cardiac index equal to stroke volume, which is 130 minus 50, minus 50 is 50, 130 minus 50, 130 minus 50, 130 minus 50, this is the stroke volume, times heart rate is 80, 80. Then in our formula, times 60, the 60 of the body surface area. The surface area. So then divide by square root, the square root with the weight, which is unknown, times height. Height is 160. Height is 160. Height is 160. See, now, cardiac index 3.5 liter, يعني 3500 ml equal to, this one is 80 stroke volume, heart rate is 80, 60, this one, it was here divided by 3600, we say out of 60, recipient above, so this one times 60, over square root weight times 160 height. So now how to solve this one? Calculation is equal to, we can use the cross product, so we can use the weight times 160. Really, this one is times here. This one multiply this one by 3,500 times this one 3,500 cardiac index equal to, this means like as 1 over 1. So we multiply then 80 times 60 times 1. And this one will be 80 times 80 times 60 times 1. So that is mean. Here we have, that is mean here we have here. Let me have here equal to square root weight times 160, we divide by 3,500 first. So then we have 80 times 80 times 60 over 3,500. To find the weight, you have to take the square both side. So the square both side. Now this one is the left side square, or this side square. Then what you have? We have weight, okay? So we have weight times the weight times what times 160 equal to this all together. We have here, can use the calculator. By the calculator, this one altogether is 80. We have here 80 times 80 times 60 over 3,500. So this one is can be written as 768 over 7 square. So now what about the weight? What is the weight equal to the weight? So the weight is equally divided by now 160. So equal now this one is equal. You have 7 6.8 over 7 square divide by, what divide by? 160. And divide by is 160. I mean over 160. And this one will be over 160. Now by calculator. So the square of this one first square equal to, and divide by 160. Divide by 160 equal to decimal. So that is mean the weight in my calculator be, the weight is equal in decimal 75.23, 75 kilogram. Here the answer. So this is the end of this video.